Just so you know, if you go to the front of this, in the booklet at the front, and then at the bottom of this, it kind of tells you what this unit is all about. First, we're going to deal with triangles. We're going to classify them. What does classify mean again? To name them, right? We're going to name. So naming. Okay, classifying means naming triangles. Then we're going to talk about quadrilaterals. Quadrilaterals are four-sided shapes, so four-sided polygons. We're going to talk about some formulas, some properties, and we're going to classify them as well. And last but not least, we talk about polygons. So anything, this is 3, 4, and then anything more than 4. In fact, polygons is everything. Poly is many, gons is angles, many angles. So that's, polygon would be everything, okay? So we're going to go from triangles, quadrilaterals, then polygons, okay? We're also going to classify. So classifying, just so you know, is naming them if you have a name for them. So let's go to page 6. And this is just remembering that when you're supposed to classify triangles on your study sheet, you should maybe write down right now just a little subheading. First of all, geometry. Then you're going to have classifying triangles, okay, classifying triangles. And then you're going to have by angle and by side. By angles and by side. So you're going to give them, you're going to have 3 options for the first part. I don't care in which order you do them in, right? If you first go by angles, then go by sides, it's fine, okay? What you need to remember is that an acute triangle, all angles are less than 90. What's the common factor here? 90, right? 90 is kind of like our reference. If all 3 are less than 90, you've got an acute. If you have one that is exactly 90, you've got a right triangle. If it's obtuse, then you've got an obtuse triangle. So that's what it is. And then you go by side lengths. You've got equilateral, isosceles, scalene. Okay? Let's keep going. Why can't a triangle have more than one obtuse angle? I will show you an example. Example, if you have 91 degrees, that's an obtuse angle, right? And you go 91. Oops. That's already 182 degrees. Is that possible? That's impossible. Why? Yeah, not possible since it is greater.
Excuse the interruption. Can we please get a custodian with the key to the elevator downstairs? Custodian with the key to the elevator downstairs. Thank you.
Page 6. Okay, not possible. You can't have it. So you can only have one. Could you have two right angles? Yes. Can you have 2 right angles in a triangle? 90 and 90 is 180. What about the third angle? 0? Can't have that. That's not an angle, right? So the third angle would be like, hey, what about me? What am I doing here? Anyways, here's how you classify triangles. This is a little bit of overkill. I'm not going to lie. The way I teach it is a little overkill. The province doesn't expect that much. So if I skip pages, that's why I'm doing it. Okay? When I first developed this, I wanted to go to town, and then I realized, like, wait a minute, they're basically asking very basic questions. If you know how to name a triangle, you're in business, okay? Anyways, but I'm going to tell you, look for the side lengths and angles given. Are there any markings, or are there any actual values? Look for that. Are you able to determine all 3 angles using sum of 180? If the answer is yes, you have everything you need. You can classify it, okay? So this is important. If you're able to determine all 3 angles, you have everything you need. go ahead and just classify it. You don't need to know the side lengths. I will make a note. No side lengths needed. I'll give you an example. Write this down first. If I told you that I know of a triangle that has all angles equal to 60 degrees, what kind of triangle is it in terms of side lengths? If they're all 60, we know it is an equilateral triangle. All three sides are going to be the same length. Okay? What do we know in terms of angles? Which one would it fall under in terms of angle measure? A QT. That's a good one. Such a cutie. Okay? So I'm gonna stop there. I'm gonna stop there. I'm not gonna keep going. If you know how to do that, you're fine. So let's try it. Let's try it. Here, name it. So this one right here, in terms of the side length and in terms of angle measure, what would you call it in terms of side length based on the markings? What are my three options for side length? Equilateral, isosceles, scalene. This one would be a scalene, okay? Never heard of that probably, right? Like, what is a scalene triangle? Like, my teachers never talked about it. I know, I agree with you, because most of the time we don't. What about in terms of angle measure? You've got the 190, right? This is, I was gonna go acute, but sorry, right. It's a right scalene or a scalene right triangle. It doesn't matter how you say it. This is how you classify it, classifying it, okay? What about this one here? What do these markings tell me? They're all equal. Okay, note, markings tell us all angles are equal. Page 7. Therefore, this will be what? Equilateral. Equilateral, what in terms of angle measure? We just did that. Acute, right? I'll tell you a little secret. When it's an equilateral, you don't need to say acute equilateral. But it doesn't hurt to do it. So I'll just tell you, just do it. Okay? That'd be a good name for your kid, eh? Equilateral. No? Oh, okay. Like a middle name? You don't seem convinced. I agree. That'd be cruel, right? Okay, what about this one? You see the box? Ooh, I know this one. I know this one. Thank you. Okay. What about the other part? The side lengths, these ones are equal, right? Yeah. So, equilateral, right? No, isosceles. Were you writing equilateral? Sorry about that. I'm trying to get you to wake up. Okay, that's what I'm trying to do. How do I know this isn't possibly the same as these two? What if there's a chance? When there's a right triangle, do you remember what's across the right angle? It's the hypotenuse. Remember hypotenuse? It's always the longest side. So this one has to be unique, like it's longer than these two for sure. So sometimes there's not a single number here and you could figure it out. Let's do this one. In terms of Is it possible, guys? Is it possible to get all angles? Yes? Yes. Yes, it is. Thank you. Because we've got two. Let's figure it out. 180 minus 20 minus 30. That's 130. Boom. Put this in there. Question. Do you have everything you need to classify this thing? Yes. But Mr. Erickson, I don't have a single side length. It doesn't matter. You know why? Because if all angles are different, all the sides across from them are going to be different as well, guaranteed. Okay? So what do we do in terms of side length? What would we say? Scalene. And in terms of angles, what are you looking for? 90 is your reference. There's this one that's bigger than 90, so this is obtuse. Okay? I will make a note under this. Okay? Since all angles are different, all sides are different. Guaranteed. Do you remember what across the largest angle you'll have the longest side, right? And if there's a middle angle, that'll be the middlest side. That's Mr. Isfeld copyright. And then the smallest angle will have the shortest side across from it. So they're all going to be different, right? They're all going to be different. Okay, with this in mind, before we go, I'm just going to say page 8 to 10. 8 to 11, I'm actually going to say. 11 is you have to sketch your own. You can use markings, you can use numbers, you can use whatever you want, as long as you fulfill the requirement. Okay? Thank you, guys. That's it for today. Tomorrow we'll do quadrilaterals.